Assalamu alaikum. So today we are going to design and do a simulation of 50 ohm microstrip line. So the objective of today is to design a 50 ohm microstrip line and to find the width and length of a microstrip transmission line for a 50 ohm characteristic, impedance, and a 90-degree phase shift at 5 gigahertz. The substrate thickness is given, that is 1.6 millimeter with permittivity of 4.4. In this case, we will be using F4 FR4 epoxy material. So for calculating width and length of a microstrip transmission line, we can use simply an online calculator. You can go and search for microstrip line calculator and use the first thing, that is microstrip line calculator, and that would open up this web page, and you can just put the given data as 4.4 dielectric constant, dielectric height that is 1.6 millimeter, and the frequency that is given 5 gigahertz, and also the 50 ohm impedance and elect length that is 90 degree, and then just click on synthesize and you will get your width and length. So now let's move toward the design and the simulation. First of all, open the HFSS and in the project section, insert HFSS design. First of all, the step 1 is to draw a rectangle and name it ground. You can also select colors to distinguish between the ground, substrate, and microstrip line easily. So just select the ground and you can assign the parameters as the X size would be 20 millimeters and Y size would be 40 millimeters in this case, and click OK, and also assign. And now let's draw substrate. The length and width of the substrate would be the same, but the height would vary. That is, we can give the height as given in the objective, that is 1.6 millimeter, and click OK, and we can assign the material as with the dielectric constant of 4.4, that is FR4 epoxy, and click OK, and we can rename it as substrate to easily understand which material is which. Now draw the line, select the rectangle, here we can name it as the line, and also we can give it colors to distinguish between the substrate and the line. We can assign the parameters as the following. The X size would be 3 millimeter and the Y size is same as the substrate, and the position of the line would be 10 minus 1.5, that is 8.5, as we saw in the calculator, and the Y size would be 1.6 millimeter as given in the objective. Select OK, and we have done with the drawing of microstrip line. Now select microstrip line and the ground and assign the boundary to both of them. Click OK, and now select the face, that is XZ plane, and now move towards drawing of the ports. Select rectangle and draw 2 ports and we can give the parameters as the x size would be 3 millimeter and z size would be minus 1.6 and the position is right, and just click OK, and we can name it as port 1, and also we can assign excitation wave port, that is from here to here, and renormalize all modes as 50 ohm. To distinguish, we can also give it a different color. This is our port 1, and similarly now we will draw port 2 on the back side. Select the rectangle again, and give the parameters in the name. We can give the name this to as port 2, and also the color to distinguish. Select, and x size would be minus 3, and we are done with the assign the port. And also we will assign the excitation to this as wave port. Select new line and then define it and renormalize all modes and then finish. Now what we will do, we will assign boundary to we are done with the excitations and the boundaries with ground and the line. Now what we will do is just select this plane, XYZ plane, and draw a box and give it the radiation, name it the radiation box, and we will assign the material to this as air, and also name this as radiation box. We can just select this transparent and click OK, and also we will just assign the parameters in the position. The position would be minus 10, minus 10, and minus 20. And the x size would be 40, y side would be 60, and then z size would be 40. Just click OK, and we are done with the drawing a box. And now we'll just right click on it and then assign the boundary as perfectly and click OK. After we are done with the design, we can go for the validation check. As you can see, the analysis setup is remaining only, so we will just go here and add solution setup and add solution frequency 5 GHz, that is given in the objective. Click OK, and then go to the setup 1 and add frequency sweep from start 1 GHz to 20 GHz, and the step side will be 0.02 GHz, and click OK, and just analyze all and wait for the analysis to be done. As after the analysis is done, then we will just go towards the results and create model solution data report, and from here we can generate our rectangular plot. We can plot these all as parameters and click on the new report, and we can see that we have our simulation result. So that is all for today. Thank you so much.